Now we'll be talking about the complex number system. So complex numbers include imaginary numbers. So you'll see a lot of times they'll say write your response in a plus bi form. So this guy right here. So a plus bi. And that splits our complex number into a real part and an imaginary part. So this little I is the imaginary part. And down here, there are kind of two rules that I want you guys to focus on. Well, maybe three, but two to start with for complex numbers. Rule number one is the square root of -1 always simplifies to I. So never write in your final answer a square root of a negative. Always simplify to I. And then I squared should be simplified to -1. Okay, -1 can appear in your final answer. I squared cannot. All right, so just as a quick example, square root of 4, we all know that that equals 2. We use the principal square root, so it's +2, right? Square root of 4 equals 2. If we're asked to evaluate square root of -4, we could say it's not a real number, which is accurate. That's because it would have an imaginary component. It would be an imaginary number. So now in this section, we'll go one step further. And we'll say that the square root of -4, we could simplify this as square root of 4 times square root of -1 by our product rule. We know the square root of 4 is 2, and then we now know that the square root of -1 is I. So in this section, when they ask us to simplify square root of -4, yes, it's true that it's not a real number, but we're going to go one step further and say we can simplify it as 2I, this imaginary number, which is in the complex number system because there's an imaginary part. Okay, also, as you're going through these, I recommend that your first step be to pull out your I. So always pull out your I. When you see a negative under the square root, just get that I out of there just as your first step so that you don't forget. So in these two examples that are already written out, we're asked to write each square root in that a plus bi form. We have 4 plus square root of -9. When I see that negative under the square root, I know that's going to come out of my square root as an I. And notice that it's not square root of I in the final answer. We don't just turn the negative sign into an I. We get it out from under the square root sign, and then it becomes that I, that imaginary unit. Okay. So 4 plus square root of -9, we can rewrite as 4 plus 3i. The square root of -9 converts into 3i. 3 from the 9 and I from that negative sign. And then over here to the right, 1 minus the square root of -40. That negative underneath the square root sign comes outside as an I. And then square root of 40 simplifies to 2 square roots of 10. Remember that for the square root of 40, we can break that apart into the square root of 4 times the square root of 10. And then the square root of 4 is 2, which simplifies. Square root of 10 stays under that square root. We can't pull out another square root factor there. Okay, so looking at number 1, it says write each square root in a plus bi form. So first, I'm just going to pull out my I. 5 plus I, square root of 4. Oops. And then we know the square root of 4 is 2, so I could write 5 plus I times 2. But I'm just going to make this look prettier as 5 plus 2 times I, 5 plus 2I. So that's my final answer. Even though I is not a variable, it's an imaginary unit, in terms of formatting, you can kind of think of it as though it's a variable like x. So just like we would never write a final answer 5 plus x times 2, instead we would write 5 plus 2x. In the same way, we're going to write 5 plus 2i, not 5 plus I2. All right, next up, number 2, 1 minus the square root of -20. I'm just going to pull out my I first so I don't forget it. So 1 minus, get that I out of there, and then we've got square root of +20. All right, and now I want to break apart the square root of 20. I want to think about any perfect square factors that divide evenly into 20, and 4 comes to mind. So using the product rule, I can rewrite the square root of 20 as the square root of 4 times the square root of 5. And then square root of 4, of course, can simplify to 2. So I've got 1 minus, the square root of 4 becomes 2, I still have that I from before that I pulled out. And then I bring down that square root of 5. 1 minus 2i square root of 5. All right, number 3. First step, let me pull out my I. So I have I times the square root of positive 45. And now I want to continue breaking apart square root of 45, fully simplify that. So perfect square factors that go into 45, 9 comes to mind. So I can write this as square root of 9 times square root of 5. I'll carry down the I just so I don't get confused. So that I is still out there. Square root of 9 simplifies to 3. Carry down my I, 3i, and then I keep the square root of 5. I can't pull out any more perfect square factors from that. Okay, so the next section, we're going to be adding, subtracting, multiplying, and then eventually dividing our complex numbers as well. And remember our two rules. One is I squared equals -1, and of course the other one is that the square root of -1 simplifies to I. So we can have -1 or I in our final answer. We can't have an I squared or a square root of -1 or square root of a negative number in a final answer. And I told you guys that I like to pull out my I first. Here's the reason. If we go down just to this little side example, I just want to point out, if you're asked to multiply, for example, square root of -4 times square root of -25, first pull out your I, right? So that would be I square root of 4 times I square root of 25, which simplifies to 2i times 5i. 2 times 5 is 10, and then I times I is I squared. And then that I squared turns into a -1, giving me -10. It's tempting to do this down here, square root of -4 times square root of -25, multiply under the square root to get square root of positive 100, which is positive 10, but that's incorrect. So that's why I mentioned to pull out your I first. So in case that comes up in the section, just remember that rule. -10 would be the answer here, not positive 10. Okay, and we can make sure we get that right answer as long as you pull out your I first whenever applicable. Okay, so looking at these examples, again, I is not a variable by any stretch of the imagination, but you can almost think of it in terms of formatting like it's an X or a Y, like it's another variable. So for example, if we have 4 plus 5i plus 2 minus 3i, we're just combining like terms here in this first example where we're adding 4 plus 2, right? Add up to 6. And then our like terms, positive 5i, negative 3i. 5 plus -3 gives me positive 2, and then we carry over the I. Okay, so we're basically just combining like terms here. Same thing when we subtract our complex numbers. We'll have 4 plus 5i, distribute that negative sign to get -2, and then negative gives me plus 3i. 4 minus 2 gives me positive 2. 5i plus 3i gives me that positive 8i in our final answer. All right, when it comes to multiplying, we'll distribute here. So negative 3i times 4 is negative 12i. Then we have negative 15i squared. And then just remember that we can't have I squared in a final answer, so we convert that to -1. This gives me negative 12i minus 15 times -1, which gives me negative 12i plus 15. Or we could also write positive 15 minus 12i. Oops, sorry, and I dropped my negative sign there. Negative 12i plus 15 or 15 minus 12i. Either one is fine. The order that the terms appear in doesn't really matter. This is more the a plus bi form, just following that format, following that order, but this would be fine as well. So the order doesn't matter as long as you have your two separate parts, your real and imaginary. All right, and over here we've got a FOIL example. So we've got 8 minus 12i plus 10i minus 15i squared. And again, we'll convert that I squared into -1. We also combine our like terms here in the middle. Negative 12i plus 10i simplifies to that -2i. And then we have 8 plus 15 because of that double negative, so that's where we come up with the 23 minus 2i. Okay, so looking at these examples on the next page, starting with number 4. So we have this plus sign in the middle. We're going to be basically just combining like terms. And a common mistake that I see in this section is people want to FOIL something like number 4. I don't know why. Maybe you like making your life hard. I'm not sure. But please don't FOIL this. If there's that plus sign in the middle or a minus sign, like in number 5, it's not appropriate to FOIL. It's basically just combining like terms. So keep an eye out for that plus or minus sign in between the parentheses versus something like number 7, where you are going to FOIL, you are going to multiply those two together. All right, so for number 4, we're basically combining like terms. -6 plus 2 gives me -4. Positive 3i minus 8i gives me -5i. And there's my final answer, -4 minus 5i. For number 5, I just want to make sure that I distribute that negative sign. So I have 4 minus 3i from the first grouping, and then -7 plus 5i from the second grouping. 4 minus 7 is -3. -3i plus 5i is plus 2i. Number 6, distribute that -9i. When I multiply by 4, that gives me -36, and I carry down the I. Negative times negative is positive 63 I squared. And then I just want to make sure that I take that I squared and replace it with -1. So this gives me -36i and then minus 63. So this is great as a final answer. If it's upsetting to you that the I is in the first term, then just switch the order. -63 minus 36i is also correct. So either one of these would be fine. All right, and then finally number 7, distributing. So we're going to FOIL here, right? Because we are multiplying these two numbers together. 5 times 6 is 30. 5 times -5i, -25i. Then -18i. And then negative times negative gives me positive 15i squared. All right, so the first change I want to make is that I squared. I'm going to replace that with a -1. And when I'm carrying all these amounts down, I also want to combine like terms in the middle. So I carry down my 30. -25i minus 18i combines to -43i. And then plus 15 times -1 gives me a -15. And then my last step, continue combining like terms. 30 minus 15 is positive 15 minus 43i. Okay, and our last example, let's just go ahead and wrap this up. So we've added, subtracted, multiplied. We still need to divide complex numbers. And this one's kind of a weirdo because your instructions will say divide, but you're almost not dividing at all in terms of the operation. It's going to look like a multiplication problem. So we're going to create a multiplication in order to accomplish this division. So it looks kind of weird. All right, so to divide the complex number, for example, 5 divided by 1 minus 2i. So in this example, we're actually going to multiply both the numerator and denominator, the top and bottom, by the conjugate of the denominator, which would be 1 plus 2i. So notice that in the denominator, it's 1 minus 2i. Whoops. We're going to multiply top and bottom by 1 plus 2i. So we're just changing that middle sign. All right, so you can see that work down here. We start off with the original problem, 5 divided by 1 minus 2i. To accomplish this, we're going to multiply top and bottom by 1 plus 2i, the conjugate of the denominator. And then we're just distributing and FOILing. So up top, distribute gives you 5 plus 10i. In the denominator, you're going to FOIL, which gives you 1 plus 2i minus 2i minus 4i squared. And notice that in this FOIL step, whenever you multiply these conjugates together, when you do the outer and inner multiplication, you should always be able to cancel those two middle terms after you FOIL this out. So plus 2i minus 2i cancel out to 0. If they don't, you did something wrong. All right, so that leaves us with 1 minus 4i squared. And then, of course, we're going to take that I squared and replace it with negative 1. So that gives us 1 plus 4 for a grand total of 5 in the denominator. And then our last step is we can fully simplify this by splitting this up into our real part and our imaginary part. So you can always split these into two fractions, 5 over 5 plus 10 over 5i, and then simplifying gives us our final answer, 1 plus 2i. All right, so looking at number 8, the conjugate of the denominator would be 1 minus 3i, so I'm going to multiply by 1 minus 3i and 1 minus 3i, top and bottom. So up in my numerator, I'll go ahead and FOIL these. So 1 times 1 is 1, minus 3i, plus 2i, and then minus 6i squared. In my denominator, 1 times 1 is 1, minus 3i, plus 3i, and then that last step, positive 3i times negative 3i is negative 9i squared. And notice right off the bat, minus 3i plus 3i, get rid of them. Okay, so simplifying, I know that I'm going to convert these I squareds into negative 1s. And up top, I want to be able to combine like terms. So this gives me 1 minus 3i plus 2i gives me negative I, or negative 1i minus I. And then negative 6 times negative 1 is plus 6, positive 6. And then down in the denominator, 1, those two middle terms cancel out, and then I have a negative 9 times I squared. I'm going to replace that with a negative 1. So that simplifies to 1 plus 9. So up in the top, I have 7 minus I over 1 plus 9, which is 10. And technically, we still want to split these into our real and imaginary parts. So again, I'm going to split these into two fractions, 7 over 10 minus, and you can either write 1 over 10i, or you could write 7/10 minus I over 10, and that's okay too.